let's talk about transformations. Okay? How much new stuff do I need to teach you for transformations? So how many times have I taught you transformations already this year? 4 or 5? Okay. So do you think there's any new information that I have to teach you? No. I have to make sure you know what the exponential parent function is. And we need to make sure we talk about where inside and outside of an exponential function is. So you know what it looks like to make a horizontal change versus a vertical change, right? But the thing I want to tell you first to kind of make you feel a little bit better is we just finished our hardest unit in Algebra 2. That's what we just finished. Rational functions is typically the hardest unit, traditionally. Okay, so that should give you some hope, right? We're starting this unit with transformations, which you already know. You already know how to do it, right? And after this unit, which is exponential, the next unit we do is logarithms. No, you're fine. The next unit we do is logarithms. Okay? So before we even get started, I want you to know some things about these next 2 units that we're dealing with. Again, to give you a little bit more positive feelings about it. Because I know some of you have some negative feelings about math just because of what you got on your grade, on your test. Okay? So exponential functions are what we're dealing with right now. And we're going to logarithms next. I enjoy teaching exponential functions, because to me there's patterns that we can find and kind of go from there. And you know how much I like patterns. Okay? Logarithms, I actually love to teach. It's my second favorite thing to teach behind systems of equations. Okay? What's funny is that logarithms, you're never going to use them. Ever. Even the people that work in the real world application problems that we're going to talk about, they don't use them. It's all built into the computer programs that they use. Okay? But it's really fun because of the applications that you can use for logarithms. Those are fun to talk about, fun examples for us to do. And I have some really great stories for you for logarithms. And you know how much I like to tell a good story. Okay? So, but what I want you to know before we even start is that these 2 things are related. They're related like quadratics. Whoops. And square roots. They're related like cubes and cube roots. So can you tell me the relationship? They are. Absolutely. These 2 are inverses of each other. So you remember we did quadratics first and then we did square roots, and you guys were like, oh, this is easy because we already know it because of quadratics. And then we did cubes, and then we did cube roots after that, and you were like, oh, these are easy because we already knew all the stuff from cubes. So that's going to happen here. Now, they're all inverse operations, but it's easy to figure it out because of the fact that you already know the operation, so finding the inverse of the operation is cinchy. Okay? So that's where we're going. So let's talk specifically then about transformations. Okay? First of all, I need you to understand this. Y equals x squared. Is that an exponential function? What makes something an exponential function? So that's what they said earlier too. If it has an exponent, it's an exponential function, right? Not right. No. It's a good thought, right? It's a good try, but we need to be more specific. Just because it has an exponent doesn't make it an exponential function. Okay? Where does the variable have to be in order to make it an exponential function? It has to be in the exponent, doesn't it? So, for example, y equals 2 to the x. Is that an exponential function? Yes. Okay? When my variable is in my exponent, that's what makes it an exponential function. This one has an exponent, but it is not an exponential function. In fact, what kind of function is it? It's quadratic, right? It's a parabola. The graph is a parabola, so it's a quadratic function. Okay? So here's the deal. Here's the part that sometimes people let be confusing, and you are just not going to let it. Okay? This is the parent function for quadratics, isn't it? This is a parent function for exponential. Because so is this, and so is this. Those are all parent functions. But they don't look like parent functions, do they? Because they have a different number in them every time. I thought parent functions had to be like one thing. Well, when it's like this, it is one thing, isn't it? But when we have an opportunity for a different base, each base is its parent function. This is a parent function when the base is 2. This is the parent function when the base is 5. This is the parent function when the base is 1/2. And I know it's the parent because nothing is being added or subtracted or multiplied times this function, right? That's what makes it a parent. So are you okay with the fact that there could be multiple parents? Can there be multiple parents here? No, right? If I change this number, that's not a quadratic anymore. Maybe if I change it to a 3, that's a cubic, right? Okay. But the next thing we have to figure out is what makes a vertical change and a horizontal change. Well, what makes it over here? What if I say y equals x squared plus 2? What kind of change is that? It's vertical because the 2 is on the outside. So we have to figure out where outside and inside is on an exponential function so that we are sure that we know what we're talking about. Okay? Do you have any guesses? Yes, ma'am. So inside is probably in the exponent, is what she said. Do you agree with her? I do, if that helps. Okay? So if I say y equals 2 to the x plus 1, where does this move compared to its parent? So horizontal shift left 1. Got it? So if that's inside, where's outside? Y equals 5 to the x power plus 2. Can you tell the difference between inside and outside? This is a little baby number up high in the exponent. This is a regular size number, the same as 5. So what kind of change does this have compared to its parent? So vertical shift up 2. Got it? So tell me about this. What will people try to do wrong every single time on this problem? 4 times 1/2 is 2. Oh, that's 2 to the x. Can you do that? No. What if it looked like this? Y equals 4 1/2 x. Can I multiply them now? Guys, what's the only thing being raised to the power? Just the 1/2. I can't multiply according to order of operations. I cannot multiply until I take care of the exponent. And since the exponent is a variable, I cannot multiply. Period. Okay? So what kind of change does this cause? Well, where is the 4 compared to the exponent? On the outside, so it's a vertical change. It is a stretch. Why is it a stretch? Because 4 is greater than 1. So vertical stretch by a factor of 4. Correct. My multiplier is greater than 1, so that makes it a stretch. If this instead said 1/3, that would be a vertical compression by a factor of 1/3. Got it? Is any of this new stuff only the shape of the original function, right? All this stuff that we're talking about over here, we've talked about it before. Do I need to give you 84 more examples of that? You got that okay, right? Okay. The other thing you're going to have to be able to do is graph. And there's some things that I want you to know. Which one of these are exponential? Both. Okay? So this first one has an equation of y equals b to the x power. And the second one has an equation of y equals b to the x power. Seems confusing until I remind you that in this first equation, b has to be greater than 1. I have a guess, I don't know for a fact, but the word base starts with a b, and that's the base of the exponent. So this one starts really low and gets really high, like some of you. This one over here has a base that's what? If this one's greater than 1, what's this one? Less than 1, but also greater than 0. That's exactly right. And it starts off really high and gets low, like some of the rest of you. Okay? What's this one called? Do you remember? Correct. Do you remember this at all? We did talk about it at the beginning of the year. Okay? It has been a while since then, so that's why I chose to remind you. Okay? Do you notice that on my graphs I was very specific about this point right here? Any ideas why I was specific about that point? It does cross the y. Does it cross the y at 1 every single time? Every parent function? Every parent function. Because no matter what this base is, if I raise it to the 0 power, what do I get as an answer? Anything to the 0 power is 1. So every parent function will always pass through the point 0, 1. Okay? Now it'll change shape after this depending on what b is. If b is higher, it's gonna be more like here, right? Or steeper, or steeper, or steeper if b keeps getting higher. If b is getting closer to 0, this is going to be a little flatter right here. Okay? I think I said that right. If not, you can figure it out. It's not a big deal. Okay? But the thing is, I really specifically pointed out that particular point on the graph for this reason. If we're graphing a parabola, what point do we move? We usually move the vertex. Now we know every single point is moving, right? Every single point is doing the transformation that it says, like in this case going up to, but don't we usually go up to, put the vertex, and then draw the rest of the parabola? Guys, this is the point that we're going to move in an exponential function. If it moves up to, we're going to move up to and then draw the exponential function. You see what I'm saying? That's the point that we're going to move around. Because it's easier if we have one point and then everything else kind of follows along. You understand, though, that every single point is moving up to. But if we have one specific point we can go to and start that shift, then that's what we do. That's the point we're going to use for exponential functions. Okay? So in your homework tonight, you have 17 through 24. In 17 through 24, it gives you the parent and then gives you another function and says, how does this function move to its parent? So you're writing this. Okay? In the second section, the 35 through 38, it's telling you, here's the parent and here's the words. It has a vertical stretch by a factor of 4. Give me the new equation. So both times you know the parent, and you either know the new equation or you know the words of the new equation and you're asked for the new equation. Does that make sense? Any questions?